Hello everyone, this is Sudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. Today I will discuss a particular topic of Power System 1, and the subject of code of this subject is EE502. This subject is designed for the 5th semester student of Electrical Engineering Department. So this is the lesson plan. So I have to cover total 6 modules from this plan. So now this one is the course outcome of our system 1. We have total 3 course outcome for this particular subject, CO1, CO2 and CO3. In CO1, understand the concept of power system, know various power system components and define associate terms, know different types of power generation, understand basic performance of power system. These are the topics, these are basically the outcomes. So now today's topic of discussion is problems of corona that we already designed or already takes 2 lectures on corona. The first one, there was some how the corona form or the method of corona formation, then different types of voltage. And in the second lecture, we talk about the reduction method of corona, the advantage, disadvantages of corona. So please go through that previous 2 lectures. That will be very helpful for all of you. And with the help of first and second lecture of power system corona formation, today we'll try to solve some problem of corona. Now, the first problem, consider a 3-phase line has conductor 2 centimeter in diameter, spaced equilaterally 1 meter apart. If the dielectric if the dielectric strength of air is 30 kV max per centimeter, find the disruptive critical voltage. So this is our aim from this particular lecture. We have to find disruptive critical voltage for the line. We already defined that what is disruptive critical voltage, how to develop the equation from the system in lecture 1. Take air density factor. So we have to consider air density factor 0.952 and irregularity factor M0 equals to 0.9. So how to solve any problem, any engineering problem, like the problem of machine, like the problem of power system or control system. So to solve any type of problem, the first step, we have to identify the given values in the problem. So how can we identify? To find that the first one is, it's a 3-phase line, then conductor 2 centimeter diameter, spaced equilaterally 1 meter apart. So the distance between the conductor is 1 meter apart. The dielectric strength is also given here, that is 30 kV per centimeter. We have to find what is the question of this particular problem. The question is, we have to find the disruptive critical voltage. So that is our aim for the line. And 2 values also given here. One is D equals to 0.952 and second one is the irregularity factor M0 equals to 0.9. So remember all this part. Now, as for the problem, we have to write all the data which are given in the problem. So conductor radius, what is the diameter? The diameter is 2 centimeter. Conductor 2 centimeter diameter, spaced equilaterally. So and 1 meter apart. So if the diameter here is 2 centimeter, then what will be the radius? 2 by 2, that is 1 centimeter. Conductor space is also given 1 meter apart from each other. So 1 meter means we have to convert it to centimeter, because the diameter we are considering, the radius we are considering in centimeter. So we have to consider the conductor spacing is also in centimeter. Otherwise, there will be some problem of unit. So the ultimate result will be wrong result. The dielectric strength of the air, that is G0, is 30 kV per centimeter max, or we can say 21.2 kV per centimeter. So how we convert it from 30 to 21.2? Because we have to divide 30 by √3, then we'll get the RMS value, three-phase line. So the value will be 21.3 kilovolt RMS per centimeter. So in this way, first step is we need to identify the values which are given in the problem, and these values will help us to solve the problem. So it is disruptive critical voltage V0. What is V0? Sorry, we can consider the disruptive critical voltage as Vc. We know the equation from the first lecture. Can you remember the equation? It was M0 G0 delta R log d by r to the base E, and the unit is kilovolt per phase RMS value. Now M0 is also given in the previous slide. That is, what is M0? 0.9. What is G0? 21.2. What is delta? 0.952. That is also given in the problem. What is R? R is 1. Then log d by r. What is d? That is 100 centimeter. And what is r? That is 1. Then with the help of simple calculation, we will get that the disruptive critical voltage is 83.64 kilovolt per phase. Now, line voltage. How to calculate the line voltage? RMS, in RMS value. So we need to multiply √3 with this value. So then with the help of multiplying this √3 with this calculated value 83.64, we'll get the value of 144.8 kilovolt. So in this way, we can solve the problem. We can find out the critical disruptive voltage very easily. I think now it is clear to all of you that how to find the critical disruptive voltage. For that, we need to remember the equation only, that is Vc equals to this equation. Please remember this equation to solve any type of problem related where the question is find the disruptive critical voltage, that is Vc equals to M0 G0 delta R log d by r. And if you follow in lecture 1, then the concept will be clear that how this equation is forming, the method of forming this equation. So let's move to the second slide. The third one. Second question. Here also our first work is to identify, that is a 32 kV line with 1.956 centimeter dia conductor built so that corona takes place if the line voltage exceeds 210 kilovolt RMS. If the value of potential gradient at which ionization occurs can be taken as 30 kV per centimeter. It is 30 kV per centimeter. Find the spacing between the conductors. So here we will find the spacing, that is the distance between the two conductors. So what is our aim? To find the spacing between the conductors. This is actually our aim, this part. So let's solving the problem. First is assume the line in three phase. is in three phase. So the conductor radius R is equals to 1.956 divided by 2. The dia is 1.956. So if we divide by 2, we'll get the radius of the conductor. So here the radius of the conductor is 1.956 divided by 2, that is 0.978 centimeter. Dielectric strength of the air, what is given here, that is potential gradient at the point isolation occur takes 30 kV per centimeter, spacing between the conductor and the spacing. So how can we find the dielectric strength? That G0 equals to 30 by root 2, that is 30 given here. So the value will come 21.2 kilovolt RMS per centimeter. So in this way we can find the value of G0. No problem with this part. Now here the disruptive voltage VC, what is the given value of the voltage? That is 210 kilovolt. The voltage exists 210 kilovolt RMS. So here disruptive voltage per phase VC equals to 210 by root 3. So in this way we can find the disruptive voltage per phase, because the total voltage is 210, line voltage is 210, so phase voltage will be 210 divided by root 3, that is 121.25 kilovolt. So assume smooth conductor. So for smooth conductor, what is the value? For smooth conductor, that is irregularity factor M0 equals to 1, and standard pressure and temperature for which air density factor delta equals to 1. Let d centimeter be the spacing between the conductor. No problem. Air density factor we consider here, it is the value delta equals to 1. So we are considering that d is the spacing between the conductor and the unit is in centimeter. Irregularity factor we consider it M0 equals to 1. We are considering that the conductor is smooth, and we also know this in lecture 1 or lecture 2, that for smooth conductor what is the value of M0, for rough conductor what is the value of M0, we know all this. Now the value, the voltage is given, that is disruptive voltage. So for this case we have to consider the equation of disruptive voltage, that with the help of this same equation we solve the last problem. And remember the equation, that is Vc equals to M0 G0 delta R log d by R to the base e kilovolt. So using this problem, putting all the values given in the problem or considering some values, we can solve this problem very easily. So here M0 1, G0 21.2, delta equals to 1 we consider, then R 0.978, and put the value of no, we are not going to put the value of this, because log d by R we need to take here and calculating all these values, because Vc is given 121.25 and the radius is 0.978, so R is also here 0.978. So putting all the left hand and right hand side value, log d by R to the base e will be 121.25 divided by 20.733, the value will be 5.848. 5.848. Now using the logarithmic problem, d by R will be equals to e to the power 5.848. So e to the power 5.848 is equals to 3.348.8. So this is d by R. So the value d by R is 3.348.8 now, but we have to find only this d. So how can we find this d? D is equals to R into 348.8. We already find the value of R, that is 0.978, and the right hand side the value is 348.8. So using simple multiplication, we find that the value of D equals to 341 centimeter. So it is very easy, I think so. So in this way, you all know the equation of this part, log D by R to the base E, that is equals to 5.854, that is D by R equals to e to the power 5.854, that is equals to, so D by R equals to e to the power 5.848. So that is equals to 348.8. Now, using this calculation, easily you can find the value of this. D equals to this value, you can easily find 341 centimeter. So this is the method. This is if the problem is there, you need to remember the equation only which you develop already, and with this you have to identify that which parameters are given. So with this combination, you can solve any type of problem. Okay, go to the third problem. What is the third problem? First, identify the question. Calculate the cold loss. So we have to identify what? The corona loss. Calculate the corona loss per kilometer of the line. This part is actually the question part. This is the question part. Now find the given values. So the values which is going to help us to solve this problem. One is 3-phase, second one is 220 kV, third one is a 50 hertz. Transmission consists 1.5 centimeter radius. So here radius is given R. Conductor spaced 2 meters. So we need to convert either meter or centimeter. If we convert 1.5 centimeter to meter, then it will be meter. But if we convert it in centimeter, so it means centimeter. Part of equilateral triangular formation. If the temperature is, here temperature is given 40 degrees centigrade and the atmospheric pressure is 76 centimeter pressure. Calculate the corona loss per kilometer. Take M0 equals to 0.85. So all these values are given for this particular problem. So here loss equation you need to remember. We know that the loss equation is the very important equation. We already discussed and derived this. That is P equals to 242 divided by delta into A plus 25 root over R by D, V minus Vc whole square into 10 to the power minus 5. So this is the equation of, this is called the loss equation, corona loss equation. Now, putting all the values given in the problem, we find delta equals to 0.952. Here we assume G0 equals to 21.2 kilovolt centimeter RMS. Why we are assuming? Because 30 kV is the voltage when the corona occurs. So by division by root 2, we get the RMS value, that is 21.2 kilovolt. So assuming critical disruptive voltage, why we are assuming critical disruptive voltage first? Because there is a term, VC, V minus VC. So V is given here, no problem with V, but VC we need to calculate. So what is VC? Already 2 times in the first and second problem we calculate the value of VC. So here same equation we need to use to solve this problem. So what is the problem? Try to understand in this case, that is M0, G0, delta R, log d by R kV. So putting all these M0, G0, delta R, log d by R, we get the final value 125.9 kilovolt. So this way we can identify or we can calculate VC. So no problem with VC, this part. Equation value is 129.5. Next, go to the second slide. Supply voltage per phase. The line voltage is given to 20 kV. So phase voltage, how can we calculate this? Dividing by root 3. So 220 divided by root 3, that is 127 kilovolt. Now substituting the above values, we have corner loss as P equals to, so if we put all the value here, given value in this equation, the first equation, delta value, F R by D V by C, so we'll get P equals to 0. The value of P 0.01999 kilowatt per kilometer per phase. The coronal loss per kilometer for 3 phases. So for 3 phases, we have to multiply this value, power loss value with 3. So the total power loss, coronal loss, you can say the coronal loss per kilometer for 3 phases is 0.05998 kilowatt. In this way, we can solve the problem. Now, try to solve question number 4. So what is question number 4? Here also the problem is we have to find the critical disruptive voltage. Critical disruptive voltage. This is our aim. Critical disruptive voltage. Critical disruptive voltage. Am I right? Fine. So how can we find this critical disruptive voltage? With the help of some given values. So what are that given values? Look, this is 3-phase equivalent transmission line. Equilateral transmission line has total coronal loss 53 kilowatt. Coronal loss is given, P value is given at 106 kilovolt. Okay, a loss of 98 kilowatt at 110.9 kilovolt. What is the disruptive critical voltage? What is the coronal loss at 113 kilovolts? I think this type of problem we already solved in problem number 1, 2, and 3. So using the concept, try to clear it and submit me after the class. So we are considering this problem as our assignment problem. Okay. Now, for any issue, you can mail me or you can contact with me over phone if you are feeling any difficulties to solve this problem. Now, look this one. Solution is also given here, so it's very easy to solve. So I'm not going to the detail. Next, we are considering this as our assignment, so please go through all these assignment. Estimate the coronal loss for a 3-phase. Look here also for a 3-phase, 110 kilovolt, 50 hertz, 150 kilometer long transmission line consisting of 3 conductors each of 10 mm diameter and space 2.5 mm apart in the equilateral triangular formation. The temperature is 30 degrees centigrade and the atmospheric pressure is 750 mm of mercury. Take irregularity factor 0.85. Ionization of the air may be taken, assumed to take place at maximum voltage gradient of 30 kV per centimeter. So this is the problem. I think now all will be able to solve this one. So please submit this one also. Assignment 2, let's talk about this assignment 2. So in assignment 2, take the dielectric strength of the air be 30 kV per centimeter. Calculate the disruptive critical voltage for 3-phase. Critical disruptive voltage we have to calculate. Line with conductor of 1 centimeter radius, so no problem. R is directly given here. Space symmetrically 4 meters. So just convert it 4 meter to centimeter, then solve the problem. Now go to the next slide. Assignment 3. So for assignment 3, a 3-phase 220 kV 50 hertz transmission line consists of 1.2 centimeter radius conductor space. 1.2 centimeter radius is given. Space 2 meter at the corner of the equilateral triangle. Calculate the coronal loss of P per kilometer of the line. No problem. The condition of the wire is smoothly weathered and the weather is fair with temperature of 20 degrees centigrade and barometric pressure is 72.2 centimeters of H. So this is also you can solve. Now you have to think, you have to study the lecture 1, lecture 2, and also you have to go through this particular lecture. This is lecture number 3 of corona formation. So then if you think that what is the problem, where is the solution, why you are going to solve this problem, then you have to solve this problem. So if you think and think again and again, then you can solve this problem very easily. So in the real, after completion of your degree, if you join in some transmission distribution company, sometime you have to calculate the losses of corona, the critical disruptive voltage, the space between the lines. So using this equation, using this formula, you can easily find that. So this is a real problem you are going to face in your professional life. So this is the why and where and what. So the values, losses. So you need to understand, you have to clear the concept regarding this. And then if you think, you will find answer obviously. I'm giving the answer only for these 3 assignments. The first one answer will be 316.8 kilowatt. Second one, 220 kilovolt line voltage. And third one is 2.148 kilowatt. So these are the answer of these 3 problems. I think now it is clear to all of you. And the book I follow to prepare this lecture is The Principle of Power System by V.K. Mehta and Rohit Mehta, and few more internet. The website I also follow. So thank you everyone for watching this lecture. If any queries is there, you can communicate with me anytime without any hesitation. Thank you all for the cooperation.